So moving on to the long questions anyway. I don't want to spend too much time on this question because we've done it before, and then it's kind of just some of the later parts to it are a bit difficult, but I'm going to do it again anyway just for completeness. So again, you have to they don't give us too much information, which is kind of a good thing here. So we're just told driving on a motorway. Okay, the kind of important bit is this passes a point A on the motorway. So just like say this is point A. So she passes this and she's driving this way. And then we have the little car here. And her speed is given by this function here after a certain time t. And we're told that this gives her speed in kilometers per hour t minutes after she passes the point A for t between 0 and 5. So for the first 5 minutes after she passes this point. And we're also told t is a real number. Kind of useless, but anyway, this doesn't matter at all. So we're then told to work out Fiona's speed when she passes the point A. So first step of these questions is always the same. It's always going to be sub something in. So this one here, when she passes the point A, just look as well. They give such little amount of room to do this that you know it's going to be simple. When she passes the point A, time is 0, so sub in 0. So v of 0. So that's 2/3 minus 6, 0 squared, plus 13 times 0, so it's 109. This whole thing is just 0, and we just get left with 109. And then don't forget your unit. She's traveling at kilometers per hour. That's how you do the first part. So that's not too bad. Then we're asked to work out her acceleration. I talked about it last week as well. Kind of the whole reason differentiation was actually invented was for acceleration and velocity or speed. But what's important is acceleration is the rate at which your speed is increasing. Okay, so what that means is acceleration is the derivative of velocity or speed. So if we have v of t, and if we differentiate that, we get v dash of t, which is the same as the acceleration, or a of t we'll call it. And so again, the first step for these is always just find the derivative. You get most of the marks just for that. It's just the derivative. So any time you see the word rate, it usually means, I think it almost, especially on the leaving cert, it means derivative. So you should be thinking differentiation when you see that, or increasing as well. So what we're going to do is we're going to differentiate this function here. So when we differentiate this, we're going to get 2t squared minus 12t plus 13. Yeah. Then what we do is we're looking for it after 5 minutes. So we sub in 5 wherever t is in this one here. So just like this here. Okay, so that's 50 minus 2 by 5 squared minus 12 by 5 plus 13, which is 3 kilometers. So the answer is 3, and then just look to see if they give us a unit, which they actually do. So kilometers per hour per minute. So we're just going to write that. We're just going to copy that. Kilometers per hour per minute. Okay. Then we're asked to find the value of t at which Fiona reaches her maximum speed during the first 4 minutes after she passes to point A. So, again, anytime, like I said, when you see rate, you should be thinking differentiation. And when you see maximum, you should be thinking differentiation. All the time, or minimum. So, first of all, I'm going to write down the derivative, which we know. The derivative of our speed is 2t squared minus 12t plus 13. Now, to find the maximum speed, what we do do the same thing every single time. Anytime you see maximum, differentiate and equal to 0. So now we have 2t squared minus 12t plus 13 equals 0. And to solve this, we just use the line speed. So if you put this into your calculator, you'll get 12 squared minus 4 by 2 by 13. It's all over 2 by 2. So you get two answers, remember? So we're going to do both of them. So we're going to get t is 4.58. Just remember that's minutes. That's the first one. And the second one, we're going to get 1.42 minutes. So we have 2, but we only want 1. So you usually have to look. It usually is the same. You're going to have to kind of just throw one away. If you don't know in an exam, just guess which one to throw away. Usually for time, it's if one's negative. In this case, they're both positive. So that's a bit unfortunate. But the way you do it is it says the first 4 minutes. And obviously, this is bigger than 4. So it can't be this one. So usually, I wouldn't put an X through it. I'd usually just say disregard t is equal to 4.58. And then we could do a little implies and just say t is equal to 1.42 minutes. So after 1.42 minutes, she'll be traveling at her maximum speed. That's how you do that. Yep, that seems okay. So that's the first part. Now, then we're asked to use integration. So you need to integrate to get any marks, to work out Fiona's average speed over the 5 minutes after she passes the point A. So this is the average integral. So let's say 1 over b minus a integral from a to b of v of t dt, or dx, doesn't really matter. Then you kind of have to figure out what a and b are. So a is when we're starting. So when we start, the time is 0, and then it's over the 5 minutes, so 5. So then I'll come down here, so we can say the average speed is equal to 1 over 5, because that's what b is, minus 0. Then the integral from 0 to 5, and then what we do is we stick in this thing here, v of t. So 2/3 t cubed 2 over 3 t cubed minus 6t squared plus 12t plus 109, I think, plus 13t. Okay. Change that. Okay, and now all we do is just integrate this. So 1 over 5 minus 0, first of all, is just 1 over 5. Now I'm going to integrate the whole thing here. So what I do is I kind of put a big bracket like this. Now for the integral of the first one, I think you might have had a bit of problem doing this last week, but all we do is it's going to be, again, add 1 to the power, so t to the 4, and then that becomes over 4. But we can say that's the same as 2t over 12. 3 by 4 is 12. Now for the next one, it's going to be minus, divided by 3, minus 2t cubed plus 13 over 2 t squared plus 109t. And now we put our numbers up at the top, 5 and 0. For these type of ones, we don't have to put in 0. The times you have to put in 0 is if you have e to the x, sine x, cos x. These type of ones, put in 0. But for our one, we don't have to. So don't worry about doing that. All we have to do is just stick in 5. But if you want to do it that way, like, no problem at all. So our answer is going to be 1 over 5 multiplied by 2 over 12 is the same as 1 over 6. 5 to the 4 minus 2, 5 cubed plus 13 over 2, 5 squared plus 109 by 5. And then what we'd normally do if it wasn't 0 is we do a minus and we put the whole thing again and just stick in 0. We don't have to here though. Okay. So now we just put this into your calculator and then just remember to give it in the right unit. So 1/5, 1/6, minus 2/5 cubed plus 13/2, 5 squared. Okay, and then what does it ask us to do? To 2 decimal places. It's 112.33 kilometers per hour. That seems okay. Okay, so that one, important to know your formula for that one. Now this was one of the ones that was kind of hard to do, so I'm guessing they only gave 5 marks for this one. This one requires quite good knowledge of the derivatives of kind of calculus in general, especially kind of for what's expected of the leaving cert. It's a bit bad, but we're given 2 pieces of information. We're told that the derivative is positive, and we're told that the second derivative is negative. So if the first derivative is positive, so this bit here, that means the function is increasing, okay? So that means it's getting bigger. So there's kind of 2 ways that can happen. It can get bigger like this, and you can see it's getting bigger as you go to the right, or it can get bigger like this, okay? So the reason these are different is you can see this is called concave up. This is what we'd call concave up, and then this one here is what we would call concave down. Again, you don't really, this is meant to be on the leaving cert, it's not really taught, but the difference is that you can see kind of this one here is actually kind of getting bigger and bigger, but this one is kind of, it's slowing down. Like, see the growth here? Like, oh yeah, so if like from here to here it grows a little, and then from here to here it grows more, and then more. It's getting bigger and bigger, kind of quicker. And then this one is getting bigger and bigger, but it's kind of getting slower, if you see what I'm saying. So kind of why that's important is if you were to come along and draw the tangents. So see here, if you were to draw a tangent here, it would look like this. Then if you were to draw a tangent here, it would look like this. And then here, it would look like this. So this one is basically where this would be the second derivative is positive. While this one, if you were to draw the tangent, you can see they get lower and lower. So for this one, the second derivative would be negative. So basically what I'm saying is that our graph is going to look something like this one here. So we're looking for a graph that looks like this. So obviously straight away, we can see it's going to be graph B. So if you don't, obviously it's tough to see this. What we can do is we can eliminate this graph straight away, and we can eliminate this graph straight away. The reason we can do that is because this information here, the derivative being positive means it's increasing. You can see this one here is going down, so it's not increasing. This one is increasing. This one is going down, and then this one's going up. So we can just get rid of 2 this way. We can get rid of C and we can get rid of A. And that's what we could say. So it says, justify your answer. We can say, oh, well, basically it cannot be A or C, as they are decreasing and then we can say, and kind of this implies B is increasing. Okay, then we're left with 2 next, then we have to basically give the next one. That's how we would go about this one here. Basically we know it's not D because, like I said before, this one here is kind of concave up, it's kind of going this way, it's increasing quicker. But we're told basically when you have this thing, the double dash, that's the rate of change of the rate of change. So if it's negative, it means the rate of change is slowing down. But you can see here for this one, the rate of change is actually speeding up. So you can see it's getting quicker and quicker as we move to the right. But it should actually be slowing down. So that's why we can't, and then this is how we get rid of d. We say cannot be d, because the rate of change is slowing down. It's negative. Well, I suppose the rate of change, we'll say the rate of change of d is getting bigger, not smaller. So that one is pretty hard to do, and it requires pretty good knowledge of calculus, which most Leaving Cert students wouldn't have. This is really one for the very, very top students on the course. So I wouldn't be too worried about this one. Just maybe no, I wouldn't worry about the second derivative too much. The first one is kind of important to know. So you should kind of know that if the first derivative is positive, that means we have an increasing function. And then there's just two ways it could be increasing. Similarly, if we're told that the derivative is negative, we have a decreasing function. So it's going down over time. And again, there's two ways this could happen. It could go like this, or it could go like this. Okay? So that's how you would do this question. Now, if you see a question like this and it's one of the parts is tricky, don't get too worried, because the next part is actually pretty nice. We're told there's an average speed zone starting at point A, so we have some point here A, and then we have some point here B, and we're told the distance from A to B is 10 kilometers. And then there's a camera, we have some camera here recording the time it takes a car to get from here all the way to here, and they calculate the average speed from A to B. Okay, and then we're asked to work out the minimum time, so the quickest a driver could get from A to B while not driving above 100 kilometers an hour. So this would be the triangle, distance, speed, time. So time is equal to distance divided by speed. So the distance they're traveling is 10 kilometers, and now we have to ask the quickest they could get from A to B is when you drive at the speed limit. You drive as quickly as possible. So that's going to be when we're driving at 100. So that's going to give us 1 over 6. That's 1 over 6. Oh no, sorry, 1 over 10. That's 1 over 10 hours, but they want it in minutes. So what you do is you multiply it by 60. That's how you convert hours to minutes. You just multiply it by 60. So if you think about it, 10% of an hour is 6 minutes. So that's how you'd actually get the answer. So then t is 6 minutes. Now this is probably the hardest of any question on the entire paper. You'll have to see. I might have to go check the marking scheme midway, even after years of college maths, because this question always drove me mad. But okay, anyway, we're told Rohan is driving from A to B. So Rohan's at point A, and then he's getting to point B. He passes to point A driving at a constant speed of 120 kilometers per hour. So when Rohan passes this point, he's driving at 120 km per hour. And now we're told he drives for 2 minutes at this speed, and then he starts to decelerate at a constant rate until he reaches the point B. And then we're told that overall his average speed in driving from A to B is 100 kilometers per hour. And then we're asked to work out his deceleration. Okay, so that is ridiculous. But anyway, let's see if we can do it. So he's going to travel from A. He's traveling at 120 kilometers an hour for 2 minutes. So we can figure out how much distance he's covered, I suppose. And then I think we might be able to figure it out that way. Yeah. So first of all, you have to convert the minutes into hours to figure this out. So again, with the kind of distance, speed, and time thing, we're trying to figure out the distance he's travelled. So distance travelled is just speed multiplied by time. They do have to be in the same unit though. So the speed is 120, and then the time. So we're given it in minutes, but to convert back to hours, we just divide by 60. So like this. So that's just going to be 4 minutes, I think, or 4 kilometers. If I'm right, just double check. Yeah, 4. So he's traveled 4 kilometers. Okay. Oh, okay, this actually, I think we're going to have to use this piece of information here. Usually if they give you something, you're going to have to use it. Okay, anyway, he's traveled 4 kilometers. After 4 kilometers, he starts to decelerate. So he's at this point here. This is where A is. This is where B is. So now he has to travel 6 more kilometers. He has 6 kilometers to travel. He's slowing the car down. That's kind of the interesting thing. But we're told that his average speed is in driving from A to B is 100 kilometers per hour. So looking at the last part of the question, the minimum time, if his average speed is 100 kilometers, that must mean he traveled there in 6 minutes, like we just figured out. So that actually means that he travels the 6 kilometers in 4 minutes. So 6 kilometers traveled in 4 minutes. While decelerating. Okay, interesting. God almighty. I'm trying to even think of how. So he's traveling like this, and then he starts to slow down basically. It's linear, alright. And then the distance under this is 6. Okay. Wow. Interesting. How could I even... Maybe I need to write it as a function. Okay, I think that's going to be what we're going to have to do. I think we have to write his speed as a function. So what's his velocity going to be given as? Oh, okay. Jesus. Okay, this is interesting. But his velocity is going to be given by 120, because that's what he was traveling, minus AT. So, or is it? God, no, it's I thought, minus AT, does that sound right? Yeah, I think that's going to be right. Minus his acceleration. Or his deceleration, I guess. I think that's right. Okay, yeah, I think that's right. Yeah, that's right, sorry. And now what I'm going to have to do is, I think I'm going to have to integrate this. What am I going to be into? So he travelled, when was it? 2. So this is 2, and then it took him 4 minutes to do it. So I can integrate this, I think. The integral from 2 to 6 of 120 minus AT with respect to t. And that's going to be, the area under that curve is going to be the distance travelled, which is 6. So that's equal to 6. Okay, let's just see if that works, if that comes out nicely. So that's going to give me 120t minus AT squared 2. Evaluate between 6 and 2 equals 6. So 120 by 6 minus 36 over 2 is 18, so 18a minus 240 plus sorry, I should already do this correctly, just sound like confusing you. Yeah, sorry, I'll do it properly. Minus a by 6 squared over 2 minus 120 2 minus a by 2 squared over 2. That's equal to 6. Jeez, it doesn't seem like they gave enough room for this. Come up here to do it. So what's 120 by 6, I suppose? Should I be changing any units, I wonder? Okay, I feel like I should be changing my units because I don't see how this was going to work out, but I'll have a look anyway. So 720 minus 18a, so this is just when you simplify this. Then minus 240. It's 240, and then that's going to give me plus 2a. 2a is equal to 6. Okay. So 720 minus 240 is 480. So we're going to get 480 minus 16a is equal to 6. Okay, so 480, so 474 divided by 16. That cannot be right. Oh, Jesus Christ. What a fucking shit question. Why is it not right, I wonder? So this is definitely as velocities travelled, isn't it? Between 2 and 6. Oh, actually, now that I think about this, I have a feeling that I've made a very slight mistake. I think, see the way I did it between 6 and 2? I have a feeling this is meant to be 0 and this is meant to be 4. So this would be 4 and this would be 0. The reason I think that is because, see this function here? This function I have here, sorry, is going to give the speed after a time t. And it should be 120 here. So when t is 2, it should be 120. And then I don't know what it is here, but that's, if it's 120, it has to be 0 at the start instead of 2. So I think that might be the mistake I've made. So I'm going to correct that now. So let's come back up. So I'll stick a 4 here. And I'll stick a 0 here. And I think that should correct it. And then I have to do the same thing here. So 4 and a 0. And then let me get rid of this. And let's see if this works out now. So let's have a look. Okay, so now this is going to give 120 by 4. 120 by 4 minus a by 4 squared over 2. And then the same thing earlier with 0, I don't actually have to stick in 0. So that's going to give me this. So what's 120 multiplied by 4 is 480. So 480 minus 8a is equal to 6. 16, yeah, that seems right. So 480 minus 6 then. 4, divide that by 8. I've just gotten a bigger number. So I'm not right again. Oh, I remember the answer as well. It's 50. I remember doing it years ago. It's 15. So whatever answer, I meant to get 15 out. Okay, I'm actually wrong again. So I'm going to have to have a look at the American scheme. But yeah, this is probably like the hardest question they've ever asked on the Leaving Cert. Like they're using physics in the American scheme to do it. That's the formula for the speed. Area under the curve should be distance traveled. I wonder if I do it with different units. Maybe I'm not meant to do it with 4. What happens if I do it with 4 over 60, I wonder? Yeah, okay, actually that could be interesting. I think maybe I meant to do it with 4 over 60 up here. So this would be 4 over 60 over 60. Okay, and then let me see how that works out. So 120 by 4 over 60 is 8. So that's going to give me 8. Then I'm going to get 4 over 60 multiplied by 4 over 60. Shit, 4 over 60 times 4 over 60. And then that's going to be divided. So 16, Jesus. That gives me about 0.002a is equal to 6. So then 2 divided by 0.00. No, okay. I'm still wrong, unfortunately. I think I'm missing a piece of information. I'm doing something wrong. Okay, so you actually have to figure out his average speed for these 4 kilometers. So I'm not going to do anything like this, I guess. Okay, whatever. So we know he travels 6 kilometers in 4 minutes. So that means we can figure out his average speed. So it's going to be, what's speed? Speed is distance divided by time. So there's 6 divided by, remember to change them to the same unit, which is 90. Okay. So his average speed over those last 4 minutes is 90 kilometers an hour. So when he's decelerating. Oh, okay, yeah, this is kind of physicsy then. I don't really like this, to be honest. But basically, if you want to find, this is literally, what the hell, I'm looking at the American scheme here, and it's literally physics. Like, okay, there's a formula in physics that has that u plus v divided by 2 is equal to the average speed. So, and that's where u is the initial speed and v is the final speed. Okay? Sorry, I actually thought I could do this one with maths, but apparently you can't do it with Leaving Cert maths. You need physics to do it. That's great. So we know that the initial speed is 120. We don't know what the final speed is, but we know the average speed is 90. And we can use that to find v is equal to 60 kilometers per hour. Okay, so then basically he starts up here at 120 and he finishes down here at 60, and that's over the course of 4 minutes. So his deceleration is 60 kilometers an hour. So he slows down 60 kilometers an hour in total, and that's over the course of 4 minutes, which is the same as 15 kilometers per hour should be per minute. My God, I did not realize you cannot do that using Leaving Cert maths. That's ridiculous. That is so stupid. In every single solution they use physics. Jesus Christ. Okay, I'm sorry I even did that question. Oh my goodness. Right, don't worry about this one. Maybe leave that part.